An unexpected discovery was made by the James Webb Telescope, city lights in space located 7 trillion miles away from Earth. This remarkable finding has sparked curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri b? Could this indicate the presence of life beyond our planet? The James Webb Telescope detected these extraordinary lights while scouting outer space and transmitting data back to Earth. For years, scientists and people across the globe have waited and researched tirelessly for a glimpse of life beyond our solar system. Any shred of evidence backing up the possibility of alien life has been welcomed with great anticipation. Recently, the scientific community received what could be a monumental shock: solid evidence suggesting that life forms may exist in space, thanks to observations from the James Webb Space Telescope. As the telescope surveyed Proxima Centauri b, it picked up what appeared to be city-like lights. These lights resembled those of an illuminated cityscape, causing scientists to marvel at the implications. Could this mean there's an alien civilization out there? This possibility has left experts baffled and intrigued, as it could mark the long-awaited discovery of intelligent extraterrestrial life. If proven true, it would suggest the existence of organized civilizations beyond Earth that are only now becoming detectable with our advancing technology. NASA engineers, observing the mysterious lights 7 trillion miles away, couldn't help but wonder how long they'd been shining, waiting for humanity to catch up technologically. David Kipping, an astronomer from Columbia University, described Proxima b as tricky due to its inconsistent heating patterns compared to other planets. Normally, rocky planets absorb sunlight and emit infrared radiation, but this exoplanet's thermal behavior is markedly different from that of its host star Proxima Centauri. This made it an ideal candidate for observation using the James Webb Space Telescope, JWST, which specializes in detecting infrared wavelengths. The distinct heat signature of Proxima b presents an opportunity to uncover hidden aspects of its atmosphere. Thanks to JWST's advanced infrared imaging capabilities, scientists plan to explore the planet's atmospheric composition and assess its potential habitability. The telescope is uniquely equipped to examine Proxima Centauri b's nighttime conditions and detect the faintest rays of light in the vast darkness of space. The JWST is capable of identifying artificial illumination in space, as long as it lies within a frequency band 1,000 times narrower than starlight. Proxima b exhibits an interesting relationship between its stellar conditions and surface features. Its day side may host structures like solar panels that absorb and reflect energy, and it experiences day and night cycles similar to those on Earth. Temperature fluctuations are determined by whether or not an atmosphere exists. Without atmospheric gases or oceans to moderate conditions, the planet's day side would scorch like a black body, while the night side would freeze in deep darkness. The degree of temperature variation is a critical focus for astronomers, helping them understand Proxima b's atmosphere. Using its superior infrared imaging, the JWST can measure the planet's thermal emissions and yield valuable data. Interestingly, the telescope's orbital alignment allows full observation of Proxima b's 11.2 Earth-day orbit. With strong indicators that the planet may have an atmosphere, the next step is to analyze its chemical composition, particularly for signs of gases like oxygen, water vapor, and methane, which are considered vital for supporting life. The process of confirming the presence of life-supporting elements is complex. Even though JWST has exceptional tools for analyzing water vapor, carbon dioxide, and methane, it struggles to detect bonded oxygen, a key biosignature. However, the telescope can still search for ozone, which offers clues about an atmosphere's vitality. While JWST doesn't have the absolute capability to study every habitable world, it provides critical data for the closest exoplanets. To dig even deeper into planetary atmospheres, astronomers are turning to future ground-based observatories, like the Extremely Large Telescope, ELT, expected to begin operations in 2028. The ELT is strategically designed to peer into the atmospheres of faraway exoplanets and produce comprehensive data about their potential habitability. Until then, the James Webb Space Telescope remains a vital instrument in humanity's quest to uncover the mysteries of distant worlds. Despite its limitations, it offers transformative insights into exoplanetary exploration. One of the key goals for future telephone scopes is to reduce the overwhelming brightness from host stars to better observe light reflections from the planets themselves. This could be achieved using internal masks or massive external satellites shaped like umbrellas, similar to shielding your eyes from sunlight to see more clearly. By suppressing stellar light, these instruments will allow astronomers to more accurately analyze faint planetary reflections and assess their atmospheres for signs of life. However, there are challenges. Scientists must distinguish between gases generated by biological processes and those formed by geological activity, such as volcanoes. The pursuit to understand exoplanets and recognize true biosignatures continues, with scientists refining techniques to avoid false positives. The James Webb Telescope marks the beginning of a new era in exoplanet research, offering a glimpse into what the future of space exploration could look like. As humanity pushes further into the cosmos, we move closer to understanding the complex dynamics of the universe and our place within it. Despite decades of searching, scientists have yet to find conclusive evidence of life on any other planet. Still, the search goes on. The age-old question, "Are we alone in the universe?" remains unanswered. It's a deep-rooted curiosity that persists through time and continues to drive modern scientific endeavors. Today, the James Webb Telescope floats in space, studying planetary bodies in search of alien civilizations. Alongside it, a popular belief has emerged that some alien species are indeed out there, waiting to be discovered. In pursuit of this belief, two American astronomers, Jill Tarter and Thomas Pearson, launched the SETI Institute in 1984. This nonprofit organization aims to detect extraterrestrial life by scanning for radio signals from space. Radio waves are ideal for this mission because they travel vast distances without being scattered or absorbed like other radiation types. The SETI Institute uses the Allen Telescope Array, a group of 42 radio dishes in the Cascade Mountains of California, to search for these signals. Despite over 30 years of observation, no definitive extraterrestrial radio signals have been found. Still, Jill Tarter remains hopeful. She once said, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." That hope was rekindled by recent reports suggesting that the James Webb Space Telescope detected city lights from a nearby planet. Currently, the telescope is the most sophisticated tool humanity has to decode the universe. It orbits about 1,000,000 miles from Earth, sending back crucial data about the early universe and shedding light on the formation of galaxies, stars, and planets. Researchers are leveraging the telescope's advanced imaging tools and specialized filters to study the physical and chemical characteristics of distant celestial bodies. By isolating specific light wavelengths, the JWST does more than observe. It analyzes planetary atmospheres for even the faintest signs of life. Its capacity to measure time and space has led to several groundbreaking discoveries. Among these is the realization that there is more mass in the universe than previously estimated, hidden in vast galaxies. This new information challenges earlier assumptions about the universe's structure and history. Humanity continues to reach farther into the cosmos, and the James Webb Telescope is essential in documenting new knowledge about distant worlds. Just 20 years ago, exoplanets outside our solar system were barely explored. Since then, astronomers have identified over 4,000 exoplanets orbiting distant stars. Even with this progress, NASA views these findings as merely scratching the surface of the vast celestial landscape. Scientists believe that trillions of exoplanets remain undiscovered. Determined to find alien habitats, scientists persist in their exploration, finding flickers of hope along the way. One such moment occurred when Galileo, on board a spacecraft bound for Jupiter, used a spectroscopic instrument that unintentionally captured a unique spectral signature, suggestive of extraterrestrial vegetation. This was the first biosignature indicating life beyond Earth. That spectral phenomenon is known today as the vegetation red edge, VRE,